Thank you for joining another episode of AI Safari. It's July 20th, 2023, and I'm your host, Mark Thomas. And today we're going to talk briefly about federated machine learning. And I have us with us a subject matter expert and Dell colleague, Ed Hicks. Ed, hey, thanks for joining us today.
Thanks for having me, Mark.
Absolutely. Looking forward to the discussion. Very fascinating topic for me, and I hope for those people listening. But before we get started, will you share a bit about your background?
Oh, sure. Actually, I'm very varied background. I spent approximately 18 years as a senior principal consultant for a large telecommunication company. Prior to that, I worked at Kennedy Space Center as a audio video wideband specialist. Had my own company. Did a lot of work in the security space around video surveillance, access control systems. Then came to Dell in 2019 to work on our computer vision technology side of the house, as well as our artificial intelligence and machine learning. And ultimately, that's where I was introduced and became the business development manager to roll out our federated learning. So that's where we started to develop that technology.
That's awesome. Very, like you said, very diverse background.
Yeah, I have worked for more than 155 different companies.
That's
It's insane.
wow, that's incredible. Okay, you got me beat. So let's jump right in. I believe that most people have at least a general understanding of the components of training and retraining AI models. Whether it's traditional or even generative AI models, where both require data inputs and some require much more data than others, like large language models. But for the most part, this means identifying the data source and moving that data, that often huge volumes of data, to some centralized location where the AI model is located. But I would say with the siloed data sources and data movement restrictions, here I think about global organizations where they've got data repositories in multiple countries, or even B2B relationships where they can both benefit from this sharing of data, but they can't readily do so due to data restrictions and privacy. So there's actually this approach called federated machine learning that may be new to some. I think it's been around for a while. You can correct me on that one. But it seems to address some of these challenges by not requiring the movement of data to the model. So can you help us understand what is federated machine learning, and maybe include a quick comparison of centralized and distributed learning?
Sure, absolutely. In fact, I believe the original patents for federated learning came out of Google for their predictive text. So your cell phone was doing some type of federated learning as you start to develop your own style of doing text. What it'll do is it'll look at that and it'll compare that to other cell phones that are out there. What happens though is that data stays local to your phone. You're not sending all of your text across the network. And so the original use case for federated learning was really in that type of environment. That would be more along the lines of like a natural language processing or predictive text type of learning model. And it's very limited in that aspect, because it's generally what we call horizontal, which I'll talk about in a bit. But what happens is to that point, right? We wanted to be able to minimize the traffic going across the network, because that's a lot of bandwidth that would be chewed up to be able to do that type of predictive text. And so what happens is we basically looked at how do we keep that data on that device, and that's what they were looking at with Google. Comparing that to a centralized learning model, what happens in it? There's centralized, there's distributed, and there's federated learning. Centralized really gives me the ability to understand what's going across a broad spectrum of locations. The problem with that is we have to bring all of that data back to a central location to be able to get that insight, right? So what we do is we bring all of that data back to a central location from all of the edge devices or all the edge sites. And that could be edge being a cloud or a core or even a physical edge. That's pulled back to a data center, and then they crunch the numbers. They do a sample of the number sets, and then they'll do crunching those numbers, and they'll run variations of epochs that go through, or epochs, however you want to pronounce it, of that data to really understand and train the models based on what they picked up from that data set. So what that does is gives me a broad understanding of what I've got across the entire environment. Problem with that is it requires that we bring all of that data back to a data center, and that means that as it's moving is data at risk. So there's the ability to intercept that data and be able to capitalize on the potential opportunity, which goes back to what you were saying with like GDPR requirements or HIPAA requirements, where we can't
Right.
move that data. So distributed, though, is where we leave all of that data in its enclave, and it doesn't leave its environment. The only problem with that is you're not going to learn across different geographic environments. So you might not be able to compare what's happening here with a different part of the world, because it's going to only be the level of learning based on its local environment, which is great for fidelity and understanding of what you have for a local data set, but it's not going to give you the ability, like in the case of if I'm going to do, some type of machine learning or artificial intelligence for a vehicle or predictive maintenance, it's not going to give me the ability to understand that it's a potential fault in a product that was being developed. It's just going to tell you that I keep on having problems with this specific part at this point on this location, and I just need to change it. So, so what we look at with federated learning is we look at the best of both of those worlds, right? We take the data and we leave it where it's at, and it's enclave, it's distributed environment. But what we do is we send the models and the weights across the environment. And so what that does is it gives the ability to have that granular understanding of my local data source and set, but it also gives me the ability to go ahead and compare that to different sites and different locations as if it was a centralized model. Key point with federated learning is we secure that data locally, right? We're keeping that data where it's at, so it's not moving across the environment. So zero trust architecture, Dell's zero trust architecture would be ideal as a platform to build that on. And then what happens is, since we're only sending the models and the weights across the environment, that's all we're actually having to worry about securing. So we do levels of security around that.
Got it.
So
Okay.
I hope that makes sense.
Yeah, no, it does make sense. So the distributing learning, you're still able to train the model, but it's not as, would you say it's not as accurate as it could be?
So what distributed learning is going to give you greater accuracy for where you're at specifically, but it's not going to give you a broad sense of what I might be learning from different locations. So it's very centralized to that location, to that distributed environment, i.e., you're not going to be able to get an understanding of potentially insight cancer research as a primary example. I can understand cancer based on a specific hospital or a specific location, but it's not going to really give me insight into a global understanding of what we might have for certain types of cancers and such.
Got it. Okay, that makes sense. So
Mhm.
as you said, the federated learning approach, we're bringing the model to the data, and that's really a result of movement of the AI model weights instead of the data itself. And to me, it seems intuitive that this approach, it suggests potentially better economics for training AI models. So instead of moving volumes of data across the wire, you're just moving the weights. And there also seems to be potentially an advantage from a security perspective of, number one, not having to move the data itself, but you've also got layers of security. And I think you touched on it, zero trust, a moment ago. Can you speak a bit more about the levels of security that are included in at least our federated learning approach?
Absolutely. So there's a couple pieces to that too. The biggest one is the fact that we're not moving data out of an environment. So that security piece of it means I really just have to secure that data at rest. What we do then, though, is we put a platform in front of it, a federated learning Kubernetes type environment, where we're actually doing the ability to go ahead and reach into that data that's behind that firewall, or that inside that database. And that database isn't moving that data out of it; it's just moving that data between it and that federation point. And so the first thing we did was we realized that back in, I think it was 2018, they determined that they could actually look at that model and potentially rebuild it. So what we wanted to do is say, okay, so even if the model is intercepted, we still want to be able to protect that model so it can't be intercepted and actually rebuilt. So the first step of that was to basically do something called homomorphic encryption. Homomorphic encryption means that when I make that request from that site or that database and I reach into that federate, when I make that request, it's encrypted, and it stays encrypted through the entire process. It stays encrypted when it's actually working on that data in that model running in that environment. And then as I'm receiving that data back, it's still in that same encrypted state, and then I decrypt it. and then I combine it all together. So what that does is it creates a layer of encryption all the way out to the edge and all the way back, and we're maintaining that. Homomorphic encryption is usually very processor intensive, but since we're only looking at the model and the weights, we're actually minimizing the amount of processing required. So that becomes our bigger piece. And to your point, by the way, when you're moving data across the network, it gets very costly, right? If I'm moving all of that data in and out of a cloud, I've got ingress and egress costs. By
Exactly.
keeping it at that location, we're minimizing that. Now all we're doing is we're basically just taking a small subset of that data. And we actually saw about a 99% reduction in data across the network using federated learning, just to bring that back. But then back to the security piece of it, we layer that on top of a zero trust architecture, which Dell has a very extensive infrastructure around that, and there's so many layers of that. And then, like I said, we're only moving the models across the network, and we're only moving the weights across the network. And so instead of just doing the homomorphic encryption, we actually now added secure multi-party computation, the Alice garbled circuit, which is a way of basically obfuscating the data, secret sharing, differential privacy, and oblivious transfer between all of the sites. So that really even makes it even more secure. So now you've got 6 layers of security on top of the normal security that you would have by not moving the data. So it's a function of a couple of things. One is the architecture of physically having data in different locations. Big one, right? That's a good security element of it. And then basically, since all we're doing is moving that model and that weight, we're really heavily creating a security architecture around that. So it ultimately gives us a fairly impossible ability to basically look at that data and actually look at that model and actually be able to rebuild it based on what you're doing with that model. So it's a very secure platform.
Okay. So now so at this point, we're now moving the model to the data instead of the reverse. We have a deep level of security to protect the weights and the model as they move across the wire. I've seen a couple of different flavors of federated machine learning, namely horizontal and vertical learning. Can you briefly explain the difference between these two? And is there an advantage of one over the other?
Well, they have different purposes, right? So horizontal learning is the same features or the same. I always look at it in a column. Features are columns in a spreadsheet, and then the rows are the different sites. So with federated horizontal learning, I've got the same features at multiple sites, and what I do is I basically do like an aggregate, or give me an understanding of those based on the same data sets in different locations. So I want to be able to, in the case of like predictive maintenance, understand more about my data policies. When do I need to change a part, et cetera, based on different sites. So that goes back to that structure around the centralized model of being able to get insight over a much larger area. So that's horizontal learning. It's same features, same columns, different rows, different sites. Rows are sites, columns are features. That's one side of it. But the other side, vertical learning, is actually something very interesting, because what vertical learning says, I've got the same rows, I've got the same information set. So that might be, financial data. It might be medical records. It might be something else that we want to be able to understand about an individual, but we want to maintain the privacy of that individual. So what we'll do is we'll leave that data in each one of those enclaves in its own database. And now we're doing what we call federated vertical learning, which is where we're doing basically data fusion. And that's actually really neat, because we can do both structured and unstructured data fusion. Whereas in the case of horizontal learning, it has to be the same type of data. So I can look at medical records as far as X-rays, and I can also look at the chart records as well on a person. And now I'm able to really get better insight, even though those two systems might be in different verticals where we couldn't actually share that data between them. So it gives you ability to basically do data fusion across a much larger environment. I know you're going to ask potentially, at some point, about what we do and where we've used this. And so I'll kind of walk through some of those when we get to that point. And then there's one other one that we do.
Yeah.
There's one other one that we do as well. It's called federated transfer learning. And that's actually, I think, our neatest secret sauce, right? That's where we can say, I can train from very similar to vertical learning, where I've got information on one side that might be rich text data, and on the other side, I might have a map, and I want to be able to populate that map and label that map, we can have that system with federated transfer learning actually label that map for us. So we bypass the desire or the need to have a data scientist go in there and label everything, because the system can actually learn itself. So that's a neat way of looking at it.
Yeah, that's interesting. And so not all federated, so one of the takeaways I have from what you just said is not all federated machine learning solutions are built the same. So
Absolutely.
I know there's some out there that offer federated machine learning solutions, but it sounds like they might be more aligned to horizontal or vertical. Is that right? So they're not all built the same, I guess is my
Absolutely
point.
correct. Yeah, there's for most of the ones that you see out on the market today are around federated horizontal learning.
Okay. And the one that you mentioned through Dell, that's vertical.
So the one that we do through Dell is all of the above. We do horizontal, vertical, and federated transfer.
Ah, cool. Okay. Okay. Awesome. So you mentioned earlier use cases. Yeah, I'd love for you to dig into that a little bit more. What are some of the common use cases you come across in your work? And also, given the whole buzz about generative AI and large language models, is there any tie-in into that? Is there any ability to use federated machine learning with large language models when you talk about common use cases?
So I'll take that one first. Absolutely. One of the later versions of this that we've just released is literally designed to go ahead and work with large language models, the chat GPT environments. And what we do is we basically leave that as a federated state. So that will be a data source, an enclave that we're working with. We can actually reach into that, into those large language models, be able to develop a technology to be able to do similar to what you would do with a chat GPT, but the reality is we're not pulling all of that data out or into a centralized location to do that. It's really basically kind of like a plugin that says, okay, I've got the ability to look into this data source or these language models, these large language models that are over in this database over here, and we want to be able to pair that data or work with that data that might be in multiple large language model locations databases, and now I'm able to go ahead and do that type of chat GPT information set, but I'm actually protecting that data. So I think one of the places that we will definitely see that as a requirement is more than likely in the legal field, financial fields, where they start, everybody's starting to leverage chat GPT to do things along the lines of being able to write papers for themselves. But by doing that, now you're exposing that data. So with the federated system, what you're basically doing is you're putting that behind that security architecture that we talked about. So now you're maintaining that data integrity, that data privacy in a federate, and then but you're still able to to understand it or realize the benefits of the chat GPT type of environment. So definitely something we would see. One of our first use cases for the overall platform really was that vertical learning piece, which was something that we did for tracking and predicting COVID across the entire country. And in fact, actually across the globe, we were looking at about 150 different data sources to 200. Each data source was giving us about 1,500 data points per person. We looked at about 4 billion people, and we were able to look at about 11 trillion data points total. And we were able to leverage the learning models that we were developing, which we had about 1,400 different scenarios. And we were able to determine the spread of COVID across the globe with about 94% accuracy, 93, 94% accuracy at 90 days out. So that gave us the ability to suddenly leverage the platform to do things like, move hospital beds where they needed to be moved, move resources where they needed to be moved. We would understand that there might potentially be an impact to a specific school district or a fire station, and so we would notify. We were working with the National Northern Command, National Guard, etc., to be able to inform those individual teams where there might potentially be needs. And so that was actually one of our projects, literally one of the first, if not the first, use case where it was actually very widely used as an authority to operate in the federal space. So that's a good example of that federated vertical learning, because that was looking at different data sources that were in different silos across the entire globe. We were gathering information from everywhere.
That's interesting. I don't know. I think we have time for just one more, because I've got a whole list of questions to ask you, but not enough time to do it. Can you just very quickly, tell us how? And I've read, and from our discussions, that federated learning can also be used to create a marketplace.
Oh, absolutely. Yeah,
Can you explain just a little bit about that?
sure. Yeah, that was actually one of our first forays into our partnership. In fact, when I first hired on, that was actually part of the stuff that we were looking at working with, and that was to basically create a blockchain-enabled smart contract structure that says if I'm a university or a company and I want to be able to share my data, but I don't want to share. I want to share my insight into my data, but I don't want to share my data. What we did was we created a marketplace that allowed you to go ahead and share that information, and which we still have, obviously, the ability to share that information into a web interface, and then that we put the federate in front of that. That federate then reaches into that marketplace and gives us the ability to go ahead and use that insight from that data. It logs who used it, when they used it. You can, as a provider of that data, you could say, I want to be able to leverage that data being used, 2 or 3 or 4 times, or 2 or 3 or 4 weeks, or by the drink, basically. And every time somebody touches
Sure.
that data, it gives you the ability to do a blockchain enabled smart contract understanding of what was going on, who used it, but also which gives you a fantastic governance model, but also gives you the ability to potentially commoditize that data that you actually have. So when somebody is using your data, you can actually charge for that. And the other side of that, it was also the ability to, and it still exists, to be able to sell and buy the specific algorithms that are being used. So you might find that a data scientist has a specialty in certain types of algorithm writing. What you would be able to do is leverage those models in that marketplace to be able to run that against your own environment, and that gives you the ability to basically commoditize on the actual algorithms themselves. So lots of cool things with that marketplace piece of it.
It's really cool. Yeah, that's awesome. This is a fascinating subject for me, and I hope for the listeners too. It seems like an approach that will be increasingly adopted by organizations. I think since we're bumping up against our time, I'm going to go ahead and cut it short and pivot to something, kind of a fun question. So I love to travel. In fact, my wife and I just came back from Italy a few weeks back, and I'm always curious about places people love to visit. So for you, where's your favorite place to travel?
That's a good question. I've got property in New Hampshire. I'd love to go up there and actually just spend time out in the woods. I live in
Beautiful
Florida,
place.
so yeah, and I live in Florida, so that's kind of the complete opposite of here.
Yes, it is.
Especially in the middle of the winter when it's 11 below zero up there. But no, that's probably my favorite. Although I've spent a lot of time traveling the world. I'd really like to buy. I thought that was actually one of the neatest places to visit. I'm a junior architect, and looking at some of the buildings were just fascinating. So I would probably say that, or potentially some places in Europe, like Ireland, or some of the places that I visited over there. It's most of my travel has been associated with work, so it's
Yeah,
unfortunate because you're looking at the world through the eyes of a cab.
exactly. Yep. Been there, done that. I love it. It's funny. I live in the Mid-Atlantic, and I have not had a chance to visit New Hampshire. I'm gonna have to make a point to do that.
Beautiful state, very and fantastic people, definitely.
Yeah, yeah, that's great. Well, this has been very insightful. Again, it's an extremely fascinating subject for me. And I think we need to do a follow-up session on federated learning. What do you think?
Sounds like a plan. Let me know.
Awesome, awesome. Thanks.
Thanks,
And for
Mark.
anybody listening, if you want more information on federated machine learning, please reach out to our ai.assist@dell.com mailbox, and we can continue that discussion. Thank you again, Ed, and thank you all for listening to this episode. Until next time, when we find another expert to help us navigate the wild and fascinating AI ecosystem, cheers.